Hello and welcome again, everyone. Let me introduce to our first speakers for today are Mr. Leo and Miss Sana from MBRDB. Senior Project Leader and Architect Leo Stuckart coordinates MBRDB Next, an in-house R&D group he co-founded in 2017 that focuses on experimental technologies, computational workflows, and new forms of narrative. Orchestrating collaborations with MBRDV's design studios and developing data-driven parametric design workflows, he helps the team to implement new design methodologies in their work to enhance design capabilities, reducing cost, enhancing sustainability, as well as the future impact of MBRDV's work. Architecture is an incredibly manifold field. It allows me to move from the highly specific to larger abstract questions on the relation of space to its inhabitants, sociology, music, economy, ecology, says Leo Stucker. Associate Director, Head of MBRDB Next, and architect Sana Vanderberg leads multiple teams with MERDV realizing projects of various scales, phases, and across several continents. Sana played an integral role in high-profile MBRDB projects, including Museum Beaumont's One Benin Depot, the refurbishment of the Leon Pardieu shopping center, and a visionary project for revitalizing New Delhi sanitization and infrastructure, Barakulla Springs. Sana is a versatile architect with demonstrated design achievements. Our projects are more than designs, they are solutions to specific challenges. Being able to strive for continuous improvement through exploration is what I love about what we do at MBRD, says Sana van der Burg. Today, they will be talking about, through a series of case studies by MVRDB and their in-house computational design unit, MVRDB Next, Leo Stuckart and Sana van der Burg will explore the relations between emerging technologies and architectural design within a global practice. In response to this year's IIDA theme, Reinventing Design Through Technology, the talk will reflect on these relations through three distinct lenses. What is design? What is technology? And what is re-innovation? Let's hear it from Mr. Leo and Ms. Sana.
Thank you for the kind introduction.
Thank you so much.
Yeah, and great to be here. We're still curious to also see it in the metaverse. It's our first experience in the metaverse. So thank you very much for the invitation. Sana, I think let's start.
Yep.
We'll start by sharing our screen. Is that working? Can you see us?
We're assuming that you can see our screen with black slides. Okay, perfect. Then we'll kick it off. So thank you so much for the introduction. We're absolutely happy to be here. And indeed, like Leo said, our first appearance in the metaverse. Super exciting. And yeah, happy to talk to you today. Yeah, as you said before, my colleague here, Leo, and myself are the people that actually founded MVRDV Next, and we are an in-house group that works around the clock on innovation and speculating on what the future has for us to deal with as architects and as designers. And we were very much triggered by the title of the event that you have today, Design, Technology, and Re-Innovation. And Leo and I had a brainstorm together, like what shall we do for this lecture? And immediately, actually, we figured that these three things, design, technology, and innovation or re-innovation, are things that specifically trigger us as MVRDV Next individually, and also how they come together. So that is something that we will be talking about in the coming half hour. So yeah, you've seen us, and maybe you see us here in our wonderful orange room in Rotterdam, talking to you. And we are actually representing the MVRDV office, which is a global firm. We have over 330 employees. We have offices in Rotterdam, in Berlin, in Paris, in Shanghai, and in New York. And we are here in the mothership of MVRDV, where all the design work happens. And if we start today by talking about reinventing design through technology, then the first chapter of our lecture with you is going to be design. And we will disassemble the theme of the event in 3 chapters. And I will be taking the first chapter, and that is indeed, what is design? We recently became fans of Midjourney, and every now and then, what you see, for example, with the development as Midjourney, is that technology is actually a tool for the imagination. And when you search for what is design, then this is what Midjourney generates for you. And if we look at these images, then artificial intelligence tells us that design is something that has to do with shapes and with colors and yeah, different forms. And design as such, it looks like something without context. And this is specifically what we at MVRDV are fascinated by, is specifically our designs are not just shapes or forms, but our designs are solutions to specific challenges. And this is also the let's say the mission, vision, motto statement of MVRDV, is that we create social, innovative, realistic, green, and remarkable architecture for a changing world. This is what we do, and this is our mission at MVRDV. And we figured that it would be very interesting for this event specifically to, since we're disassembling things, to also disassemble our own mission statement. So if we create social, innovative, realistic, green, and remarkable architecture, what are we actually saying with that, and how can we illustrate that through design and technology? Let's look at social first. So this is one of our first projects. This is the Bozoko in Amsterdam in the Netherlands, one of the first built projects by MVRDV. And for me personally, one of the first projects that I fell in love with when I was an architecture student in the 90s. This is a project where we were given a site and a brief. And the brief was to fit 100 housing units for the elderly into a very compact plot. And actually, the amount of square meters that we were asked to realize and the amount of units could not fit within this plot. And what we did at that point is to question the regulations. And at that point, it was not possible in Amsterdam. It was possible in Amsterdam to actually exceed outside of the plot boundary. So what we did here is, by adding extra units and by cantilevering, moving outside of the plot boundary, so by floating over the original plot boundary, we were able to realize many more units and give everyone in the block a happy and social place to live in. And even the units that you see here, it's housing for the elderly, but still, if you look at the elderly on their balcony, it is pretty rock and roll for housing for the elderly. And this is one of the things that we did, is through one intervention, which is extending outside of the plot, we made units for everyone more spacious and more pleasant. Then if we look at the next topic, so we create social architecture, we also create innovative architecture. And we just spoke about pleasant spaces and space for people. This is in Europe, the dream, where you have your own house and your own plot. And this is, of course, not a sustainable way to densify. So indeed, if we look at land use, living together in coexistence, in collective individuality and individual collectivity, what would that mean? Can we all live together with all of our individual hopes, dreams, wishes, and needs in a way that accommodates all of us? And this is a project called the WeGo, done by the Y Factory, which is a public-private participation between TU Delft and MVRDV. And this is an example of what it could look like if we all work and live together in different units with all of our wishes and dreams and hopes combined in one slab. We also create realistic architecture. And with that, I'm going to show you the Valley in Amsterdam. This is a project that exists on the border of a central business district and a housing area. And how can we best combine the characteristics of both those two neighbors, phenomena, contexts, as you wish. And what you see here is a combination of those two, a project that is on one hand absorbing and embracing the district of the Zuidas in Amsterdam, the CBD, and on the other hand, it's extremely human, porous, accessible, with lots of green and terraces. And what we did here, this project, this is a dream, if you see it on the previous slide, but actually, we actually helped make that dream come true through new technologies, and Leo will go into a deep dive later in this presentation about how this project actually came to exist and the engineering and the technology behind realizing this dream of making something that is both human and green and accessible. And you see the project under construction, and the deep dive will explain how we actually created the project itself. And indeed also these the tiles, the specific patterns here is something we will explore later. So about realizing dreams, and again technology as a tool for realizing the imagination. Then we have two more projects to go to, which one is green. We also create green projects, and this is something that is nice to speculate on, because green is very likable. Everybody likes green, but green is a very broad term, and green does not necessarily mean green. It can also mean sustainable. It can also mean that a project is doing something with its context in a sustainable way. And this project that I'm going to show you now is a project in Bordeaux. It's a master plan that is actually realized. So if you are in the area, you can visit the realized plan. And Bordeaux is a project that was based on daylight and sunlight. And what we see here is the plot that we had, where we were given a plot in Bordeaux, and what we did is we applied the sun and daylight regulations. And if I flip back and forward, what you see is that we sliced volumes according to regulations. We divided the plots for maximum differentiation. And these streets, if you see them now, these shapes are not something you would normally imagine yourself, but this is a project that has been sculpted by the sun or designed by light, as you could see. And the last one is remarkable architecture. And remarkable architecture is, for example, the Expo 2000 pavilion in Hanover that we built as an ode to the Dutch landscapes, a collection of everything the Netherlands has to offer. But in addition to that, also we are a compact country, so celebration of triple, quadruple land use by stacking landscapes on top of each other. And for example, here the depot, Boijmans van Beuningen in the Netherlands, also a dream of hosting, but also exposing a collection of museum art pieces to the public, which is what you see here. And this is recently opened, this building, and it is absolutely a mirage. If you see this, then you think, is this real or not? And it is actually real, and it exists, and it's wonderful to see. And why do we do all of this? Because we are working for a changing world, and there are limits to growth. And we've all read the IPCC reports and the Club of Rome, and we know that we are actually consuming more resources than we have, and we are just growing. And therefore, we also take our responsibility as architects to, through our work, address the urgencies that we are facing.
Great. So what's the role of technology in all of this? I'm going to show a quick overview of the history of the meaning of technology within MBRDV's practice, already starting from the early 90s until today, and then go in depth into what it means actually right now in the changing world of 2022. Quick disclaimer, I will have to pick up pace a bit here to make it on time, so please bear with me. If you look at the origins of MBIDV, then there's a strong drive, I guess, for speculation and visionary thinking in the early 2000s, which partially maybe had to do also with economical stagnation, a lack of real-world projects, and that gives room to think and dream and be bold. And what is particular about MBIDV, and I think both of us were not there at the time, but what inspires us also to work here today was that all of these projects were really linked to the making of tools, the making of technology, digital technology. And we see in these projects a link where, in a way, a vision in this case for a region in Germany, can only be articulated through the making of a software, through the making of technology. So it's not that there's a sketch or there's an idea and then other people sit on it and develop a tool or a technology to make it, but the making of the technology is part of the making of the project. And we see that this was done on different scales. So the previous one was on the level of a region, so large territorial scale. The next one here, Space Fighter, a project from the early 2000s, was an interactive online multiplayer game where different users would fight, as the name indicates, and maximize their individual space. So exploring mechanisms of negotiation, gamification of design, and so on already back then. A bit later, within the extensive research on the Vertical Village, which in a nutshell was about looking particularly in an Eastern Asian context on densification of informal typologies, the central element of the project was this thing that's called the Village Maker. It's a software that was developed, as you can see, in Grasshopper, which would allow interactively to choose from a catalog of individual informal single family apartment units and position them in this dense envelope, and similar to the WeGo project that Sanne showed in the beginning, in real time evaluate your impact in terms of cost, structure, the views that you take from your neighbors, the sunlight that you gain, so costs and benefits, and again, an interest in negotiation and real time assessment of impact of design decisions in a complex environment. And then lastly, I think one step further, this is probably today quite familiar in anything from online shopping to clothing, fashion, to real estate, the house maker, which would allow basically anyone, not only architects or experts, to design their own houses. So also here an idea, I think, how technology can help to make architecture accessible, understandable, and just include more people. So in a way, participation. So all of these tools from the early 2000s inspire us, but we're not part of them. And of course, as we know, the world is changing. We have to reinvent, re-innovate. So a couple of years ago, 5 years ago, Sanne and me started MBIDV Next, which is an acronym for New Experimental Technologies. So the interest was precisely to have a unit within MBIDV that is part of the workflows and of the making of projects, but also can take a bit of an observant or analytical position on it, and understand the workflows, see where things can be improved. But then also, that's the new part, then also the experimental part, break out of that, see what is happening in the world, adopt technologies that are made outside, bring them in here and change and reinvent and challenge the way that we make projects. So if this is what MBIDV does programmatically, then we like to think of ourselves in a way as the backend, as the developing the processes that feed into these kind of projects, that enable them, that nudge them, that optimize them, that maybe in the end at some point might even be invisible in complex geometries, but that actually make them feasible, remarkable, responsible, and so on. So if we want to look at our role of MBIDV Next and maybe also of how we apply technology at MBIDV, we can distinguish it in two directions. On the one hand, we can look at applied to versus speculative design. So I think particularly the role of technology has this really interesting gap or bridge between things that are useful right now that can immediately prove their value in a very short term. But then at the same time, also, of course, you can think further ahead, and it allows you to speculate on maybe the way we'll design in 10 years or 5 years, 15 years maybe. But of course, that's if you think of how fast things are changing right now, then it gets challenging. So basically, and then in the other direction, of course, we work on the left, very integrated with the workflow of MBIDV, directly with design teams all throughout the office. And at the same time, on the right, we work more independent. We work with academia, and we initiate our own research projects. We'll show examples for both of those later. So a quick overview of what we do. We do design space exploration. This is an example of a project in France where we had a preset of floor plans that was defined. And the interest was like, how can we stack them? How can we combine them to create a building that in 3 dimensions creates new qualities? And how can we quantify those qualities? So in this case, we actually brute forced, I think, a combination of 7 floor plans over 9 levels, which ended up with a catalog of I think in the end it was 73,000 possible configurations, and we built this Explorer then that would allow you to, as you can see in the graph on the left, prioritize amongst different scores or parameters such as views, structural impact, amount of terraces, daylight and qualities, and so on. And you would draw a graph in which of these factors you would prioritize in a solution, and then the algorithm would give you a top 20 out of these 73,000 solutions that would match the closest the profile that you would define. We're also interested in the relational datascape. So how can we use forms of big data through technology, read that and use it as a direct design driver? In the case of the Floriade that opened a couple of months ago here in Almere in the Netherlands, we were working from the beginning of the project. It was a 10-year planning and design process. From the beginning of the project, we worked with several landscape designers and architects. And as this spreadsheet or this data set of species of plants for the Floriade was developed, maybe I should add that it's a garden show that happens every 10 years in the Netherlands. We would develop a backend or a technology that would then update the master plan and the positions of plants and evaluate synergies between plants and all that kind of stuff in real time as different collaborators would add information here. Similarly, we also built our own datascapes. This is a master plan that we for a competition that we developed in Shenzhen in China for Tencent. And in the project, the geometries that look rather complex were mainly modeled by hand in Rhino. But then, as they are so complex, it's hard to evaluate them and to compare them and choose directions. So we built a datascape essentially of design options, and that's what you can see on the right, where you can see complex comparison graphs for feasibilities of these different options. And we can also then evaluate, of course, each of the buildings themselves. So on the left, a catalog with attributes for footprint versus floor area, facade ratio, and so on. And then on the right, we can scatter plot them and see which of these buildings are actually efficient and which ones need to be revisited or redesigned. Then, of course, another part is just then design to production. So how can we optimize rationalized designs, complex geometries? What you can see is here is a project where we built an engine that essentially was incorporating both internal requirements for square meters, accessibility, of course, and so on, as well as, of course, the external factors such as the site boundaries and offsets of neighboring buildings. And you would have a building that you would have a design that you can nudge and pull and interact with, but it would fight back. And basically what fights back then is regulations and all these parameters that are embedded in the technology that we made specifically for this project. This is maybe just interesting to show that also as technologies get complex and that also the literacy and the way in which we communicate these technologies is important. So one way that we do this is through meta modeling. So in a way to drawing diagrams of algorithms, so drawing diagrams of workflows and processes in order to communicate them and also for ourselves keep track of course, of the decisions that are taken in the programs or in the software. Then I guess an obvious one is to develop new methods to work with the environment. Sanne already showed the Bordeaux project where this was actually realized. We also developed our own computational solution, which you can see visualized here. I will go in detail into this, therefore I'll skip it now. I will also, I think, skip over this. And maybe a last one, thinking about metaverse and these kind of things, is also that we can see technology as a way to think just about scenarios. So no ideas of maybe of optimization and rationalization, but just of collecting ideas in a digital space and visualizing them easily. We did this in Bangkok in a projection of for futures and scenarios in Bangkok. and essentially generated this collection of ideas and visions and just superimposed all of them within a large model of the city. And it allows to talk about things specifically for locations, an intersection, a crossing, but then also this kind of zooming out and just these multiple perspectives and on the complexity of different actions, interactions, and interventions. So I think that's something that could link to the metaverse. And next one is like this dream, I think, of real-time design. And what you can see here is a lecture of one of our associate directors, who at the facade fair talks about, I guess, complexities and compositions of different facades and materials. And then the event evolved into this participatory process of discussing together with the audience and, in a way, designing this project. So in the back end, one of our colleagues was adjusting the code in real time, changing materials, facade compositions. It was essentially a software built for real-time design. We call it live scripting. And then, of course, also prototyping, physical prototyping, so bringing digital elements into physical actuation. What you can see was at the same facade fair prototype for a kind of portal to interact with each other. So it's a wall that where you have proximity sensors and cameras on both sides. And as people would approach each other, the portal would open and you can see each other through it, so through two screens and the webcam feeds. But if there's no one on the other side, it would basically just visually give you this illusion of a larger space by bulging virtually. And then I guess another interest that with any form of live or interactive design is then the making of interfaces. So how, as a user, how do you visually communicate through software the costs, benefits, and the impact that design decisions take? And I think this is something where technology has a really interesting role, because it can help to make these kind of processes, complex processes of urban design in particular, understandable and maybe more approachable to a general and larger audience. So quick first deep dive into the valley. How did we turn this from a bold design and beautiful renderings into a realistic, as one of our statements, project? I guess there are two parts to it where technology played a decisive role. The first one is in the optimization of the massing. So what you can see here, this was in collaboration with AROP, AROP's computational design unit. And it was essentially an algorithm that would explore different angles and combinations of massing and evaluate them both according to standardized modules for facade length, as well as to the impact of shading in the summer and heat gain or solar exposure in the winter. So it's quite interesting because in the end, what this algorithm exploits then is the difference of the solar arc between the winter, where you want a lot of sun to heat the building, and the summer, where you want as little as possible. And again, here, you use technology, algorithms for generative design. You're immediately confronted with this infinite array of design possibilities. Here we see, again, that then scoring is a key element to do. In green, options that perform better, and in red, obviously, options that perform less good. The second part here, and I think that is something that might look unspectacular at first, but actually, when you visit the building, is, for me, probably the most essential part of it, was the facade of it. And this is one of our first long-lasting projects that we did develop with MBRDV Next, all the way from the concept and the design of the facade to delivering construction documents. And we developed a workflow here from the Revit model. So at that time, the project was already in Revit, to a more flexible design in Rhino and Grasshopper, and then communicating or sending that data back into the format of the facade engineers and cost calculators. And again, here, the question of intuition or intuition of designer was very interesting for us. And as you can see, we developed an engine that would propose design facade pattern alignments. So there are several rules embedded here, from the modularity of facade of tile length to specific rules for edge conditions and so on. And then as a designer, once the algorithm proposes a solution, you can just select curves or elements within this, and it would keep on iterating different combinations. As soon as you're satisfied with the composition, you just deselect it, and it will store that result. Then, of course, there's the other part to this, from intuitive design to just monitoring of impact. So here we can keep an overview and keep track of the distribution of tiles, the quantities of different length and height. And that helps, of course, to keep costs under control, communicate with clients, and just show, I guess, a general awareness or understanding and control of the process. Again, questions of visualization of these processes fascinate us. So in the end, the project only had 4 different tiles plus exceptions, A, B, C, D, plus 2 exception tiles. And we developed this methodology to just actually project those codes on the 3D model. And then again, you see the project as a form of a datascape. So the build project we already showed. And I think at MBIDB, we can be proud of a project with pristine detailing. This one is, I think, achieved that. And I really think that the technology here, the digital process of how this was developed, is key to the success of the building. And that brings us to the third and last part, to reflect on maybe what is the role then of innovation and re-innovation. So if the world is changing and has been changing before, first of all, I guess we have been always innovative, and that is not something new. We also think that it's interesting that out of the 3 questions that we asked from Midjourney, this is one where there's a strong certainty of putting people into the center of it. So design, abstract gradients and shades, technology, something with screens. Mostly, I guess, at this point, technology can be understood then as digital technology, but innovation needs people. And I think we totally agree with that. We rarely have these moments of absolute illumination as visualized here. But I guess for us, innovation began with 3 very innovative young architects in the 90s. So we will use this moment just to introduce our practice as well. Winnie Maas, Jakob van Rijs, and Nathalie de Vries. And at this point, we have 300 innovative people worldwide. You see some here. And I think that's really the key also to making these kind of projects and to bringing in different ideas and, I guess, coincidence and chance, which is, I guess, the key also of innovation, random encounters, thoughts, how people come together and how to facilitate these communications. You can see that we work now, I think we have done around 1,300 projects worldwide, 6 continents. And we never really showed this slide before in presentations, but we think it's very interesting just to maybe take a step back and see how MBIDB as a corporate structure enables and facilitates innovation. And essentially the way that we operate here is we have 8 design studios that are loosely based on geographical parts of the world, therefore have an understanding of context, legal, cultural situations, and so on. But in the growing of as MBIDB grew, we also realized that leads to some form of isolation. So studios develop habits, customs, and repeat them. And therefore, MBIDB created specialisms. And as you can see in this diagram, specialisms collaborate with all of these different studios. We also collaborate with our 4 satellite offices in Shanghai, Paris, Berlin, and New York. And therefore, I guess the role of specialisms is not only a role of knowledge and technology and development, but also one of communication. And we like to think that this, on the one hand, informs our in-house research and development agendas. So we pick up on challenges and opportunities and ideas and innovations that happen in design projects, in studios. We, I guess, sense that, we talk with them, we help in developing these things, and we then also accelerate them into our standalone independent research and development projects. We publish these things, so of course that's a key as well to communication, not only internally but also externally. And we also collaborate with universities worldwide. This is the think tank, the Y Factory that Sanne mentioned in the beginning. They also publish a lot on visionary cities. We will not go into detail into that right now. I see I have 1 minute to explain a full project now, so let's try to keep the pace. Wanted to show one project of an innovative project, in our opinion. So that's this is a standalone project that was developed as a research by us, by MBIDB Next, called Solarscape. And as you can see, this is the format that we developed. So we make research and we publish this research internally to the office in the form of research reports. Solarscape is one of those, and Solarscape began, I guess, with the observation that, at least in Europe and the Netherlands in particular, public building policies are changing. And they're changing from, I guess, something that was easy to understand, from restrictions. For instance, take a building envelope, take a new plot, a new development. The maximum building height will be defined by landmarks. Don't exceed the landmarks of the city. Easy to measure. Draw an elevation, you measure the height of your building, done. Nowadays, the regulations here are changing, and I'll show an example of that in a moment, to what we call at the moment performative constraints. So that means you can build higher than the landmarks, but you can't impact your environment in a negative way. For instance, through creating shadows, to creating shading on your surroundings, on public spots that are defined here as sunspots, and that becomes a lot harder to measure then. So how do you know if a building impacts, or how do you know what kind of buildings are possible without impacting your surroundings? And we actually found out about this because clients asked us. Clients came to us for feasibility studies and said, there's this site, I don't know how much I can build here. Is this interesting? What can we do? Because there are these rules about sunspots, but we don't know what that actually means. Like, can I build 200 meters? Can I build 100 meters? How can we grasp these complex geometries? Out of that, so all of these 5 projects, this is a selection of projects that happened before our research in design studios in the office that we collaborated with. And by developing technological solutions towards these, within these projects, we invented, if I may use the term, a process in the end of voxelization. I guess the model on the bottom center shows it the most clearly. Where we rasterize the building envelope into small discrete elements, voxels, and then evaluate the impact for each one of these voxels on the surrounding. And then it basically just becomes an exercise of removing the voxels that don't perform or that impact your surrounding in a negative way. And this is something that's very exciting to us because, first of all, we love pixels and voxels as a design element, but also in this case, it's very transferable. So we in Solarscape, we explore the potential of this method to daylight, to sunlight, but you could imagine attaching any other attributes to this, and it essentially becomes a 3-dimensional map of the city where you don't index streets and buildings, but just space, and each little element of space has attributes. It might sound a bit abstract, but we'll go through it right now and how that worked in the project of Solarscape. This is what you can see here is the high-rise vision of the city of Rotterdam. So this is a public urban planning document, which defines high-rise zones. So it defines areas in the city where you can build as high as you want. So Rotterdam is in urgent need of housing. There's a form of a housing crisis or shortage forming. In response to that, we need to densify. There are 4 areas in the city that were demarked. This is the one in the center of the city, where we are also sitting right now. And within the zone, the municipality defines sunspots, and these are public spaces with some particular importance, central elements, either for mobility or as recreational locations, and those are protected in a way. So whatever you build, you can build high, but you cannot impact the daylight on these public spaces, so you cannot add shadow to them. And then how to build buildings that don't cast shadow. What we do is we take each of the plots within the area that can be developed and we maximize that envelope. I think in the study, we went up to 200 meters, we rasterize them, and then we evaluate each of the voxels on whether it casts shadow on the sunspot or not. What you get at the end of this exercise is a model, a subtracted model of these voxel envelopes. And what we can see now here is the development potential of the city. So this is the amount of square meters that could be added. These are not buildings, these are envelopes in which you can design buildings, but it shows the space of possibility for the densification without impacting surroundings. And we spoke about this with developers as well as with the municipality. I think both sides very excited about it because it allows to translate a legal document that is articulated in words, mainly, maybe in diagrams, and to spatialize that and to make it tangible and understandable. And I think that's also the role that we see of technology here as a way to communicate and establish feedback loops before the making of policies at municipalities, and then also to impact or to give a voice and to show true scenarios how designers and developers, with I guess formal or aesthetic interests and commercial interests, can utilize these policies. So this is another way to quantify it or to visualize it in just how many square meters can be added. So the volume of the existing building proportional to the space that can be added to it. And I guess this is a form of a collage where we want to show that and to explore that also there's a potential through technology here that building policy itself doesn't have to be strict, that it is a process of negotiation. So in a way, all of these cities that you see flickering on the screen right now are possible if you enable the communication between developer, architects, designers, urbanists, artists, people, and the city, the municipality of Rotterdam. There's a short video. I think we will end it with that as well, which essentially shows the process of the making of Solarscape. You see a fly-through of Rotterdam. So that's, of course, also essential for digital technologies here is that there's a strong data awareness. So this is a model that's publicly accessible and hosted and developed and maintained by the municipality. So then it's easy to build technologies, or it helps a lot to build technologies on these kind of digital twins of the city. So data awareness, of course, is a key here. And as we fly, I think in the second step, I'll skip a bit through, we see the algorithm. So this is the calculation for each of the envelopes, generating the voxels that are possible, quantifying for each of them. I think in the end, we had 120 million calculations for this model to be done. And then I guess what's also interesting is then this is what I spoke about earlier, that through these technologies, we can visualize the impact or the possibilities of this, and you can immediately communicate and tell and show people what it would look like, what a building policy in the end would mean or imply for a city.
And also what you see in this in this movie is what we talked about in the beginning, is indeed technology as a tool for the imagination. And this is also how we utilize technology within the office as architects and as designers is, we design tools to design our projects. And this is something that we firmly believe in, is that architects, designers need to be able to handle and design the tools that make design.
Exactly. How to, as a designer, how to remain as a maker of a tool and not a user of the tool. I think that's our position, where the reinvention of design through technology is a central element of that. Thank you.
Thank you so much.
Anyone still there?
Thank you so much, Leo and Sana, for a very interesting presentation. If there are any questions from the audience, we would like to request you to answer.
Sure, with pleasure. I see one question in the chat that I'm logged in on the software. Is that
Yes.
for housing? Thank you. Could you just tell me which of the projects was this referring to? I guess maybe about the Paris project, and you see the stack of floor plans.
Which technological software is there for housing?
Yeah, but I think I understand the question as that it's referring to a specific project.
Maybe it's just more about the softwares we use. That could be also.
Yeah, I mean, I think I would understand it as probably referring to the EC project. And that was built in Grasshopper, so built on top of Rhino in Grasshopper as a custom plugin that we developed for the project.
Valley. Maybe it's.
Yeah, I mean, there are many housing projects, so I thought that it might refer to this one. This was built in Rhino and Grasshopper.
So, is there this question is from me. Are there different softwares used in different projects? So,
yeah, I think that there are like some main tools that we are working with at the moment. So from our side, that is Rhino and Grasshopper, of course, just because it's very customizable, so we can really tailor it to the needs of MBRDB, and Revit because it became an industry standard. At least speaking for myself, not a big fan of it, but we have to use it, and it has its advantages, of course. On an urban scale, we work a lot in GIS, of course, for data management. QGIS we use there. And then on the more experimental side, we are also working, developing applications in Unity. That's more on our side, where we're building things that are real time, that are more about interaction. Then there's some open source stuff, I guess, that we work with. That's more, again, on the experimental side. So just machine learning frameworks, Google Colab, cloud computing, and these kind of things. But I would say in a day-to-day practice at MBRDB, it's probably Rhino, AutoCAD, and Revit, and then custom plugins and extensions and scripts on all three of those.
thank you so much. I'll just wait if there are any more questions.
Yeah, I think that there's another question I see on wind. So that I guess that's referring to the last project. Thanks for the question. That is true. I guess you could extend this method to a lot of other environmental parameters. It's true that wind becomes particularly pressing. The thing is that from our understanding and what our engineers in the office tell us, wind is much easier to compensate in a way. So basically, as you build high, you get these kind of winds that are falling down on the facade and accelerate, but you can accelerate wind on the ground. But to my understanding, you can compensate that quite a lot on an architectural level. So for instance, by building canopies. For sunlight or daylight, you cannot do that. Once the massing is there, you cannot build a building transparent in a way that the sun goes through. So in a way, it's true, it would be very interesting to extend this to wind and to other elements. But I guess they can be solved. They could still be solved in turning this from an envelope, from a solar envelope, into a building or into architecture.
Yeah, and I think also the idea is that we can learn to control the things we know. For example, the sun is fairly predictable in how it moves, and by having that knowledge, we can use the data as as a design tool. And one of the things that's apart from wind that we are working with now is carbon, because we all have, like we also said before, we are in a changing world that is rapidly changing, and global warming is a thing. And we also feel that we as designers need to start understanding and designing with carbon. And for that, we also created a tool called Carbonscape, which actually achieves or aims to achieve that specifically. So how can we make informed design decisions based on how much carbon we emit with every design decision? So adding parameters that we actually know and control is very much a thing that we embed in our daily practice.
Thank you so much for this insightful conversation. There's one more question coming up. I'll just wait for that. It's the same.
Yeah,
I just received the same question again, I think.
Yeah, I think it's a really good question. Do you want to read it out loud, or should I? I also see it here in the.
You talked about solar analysis what about wind velocity? Considering as we develop vertically, the air speed and pressure vary. I think you just answered that one.
Yeah, no, no, I meant the next one. I think that the
I'm
question.
not seeing the next one right now.
Okay, I will read it out.
It's just repeated, yes.
I read it out. It says technology is a little intimidating for a normal person. So how do we convince the clients to the usage for building, design, and construction? I think that that's really a core question, and also something that we, quite frankly, underestimated in the beginning. Since of course our group was formed by people who are enthusiastic and optimistic towards the use of technology. I think that the way we do this at the moment is through examples. So I think one key is to applying technology, so the making of new technologies that we develop directly in projects, and to doing that in a phased way. So we in the beginnings, I guess, when we started this, we really thought of, okay, let's build the software, this big tool that does a lot of things, and it immediately gets very complicated and it gets hard to communicate. And then what you realize is, if you break these things down into small chunks and you first develop a little bit, you show what it does, you show how it can make a building better or faster, or how it can generate different ideas and possibilities, and then you convince people to buy into it. I don't only mean financially, but also, in engagement, or in just being convinced by it, and then you can develop it further. So I think that's really something that's key to thinking about technology as tooling, and digital tooling in design is modularity.
Yeah, and also technology, it maybe sounds intimidating, but most, maybe all of the things we enjoy are actually technology, and we play with our Xbox or with our TikTok or God knows what. But everything that we enjoy nowadays is related to technology. So also, it's maybe a bit of the term. Maybe we should reinvent technology.
Mhm.
And indeed, it's technology is fun, and it's all around us, and it's just for us to have to play with it.
But it's a really good question. I mean, I think
Yeah.
that it also shows that the way you communicate things. So that's why we also showed several examples here of diagrams and of data visualization. That there's this risk of building black boxes, that people don't understand how they work and why are the results what they are. And so that's something that we also learned over time, that making technology, building or innovating on technology, is to a large part communication, building presentations, visuals, narratives, explanations of what you do. I would say I would go as far as I think we realize internally it's almost 50-50, the time of developing and making the software
Yeah.
and the time of communicating and discussing it. So that's also, I guess, in a way surprising in the
Yep.
ratio of communication versus actually making it.
Yeah, that's so true. Like technology can do a lot, and being able to clearly frame what you want to do or what somebody wants to achieve, and how you're going to achieve that, to just explain the intent and the result is more than half the work.
So when
What's
you're
no?
talking about the time taken, so does it affect the actual timeline of a project, or you prioritize or inform the client that this is going to be the time which we are going to spend on research and development for the software? How does
Mhm.
that actually work?
Well, a good question indeed. What do we? Because now it sounds a bit like when we use technology, a project will take longer, but actually it's the opposite. What you have seen in the valley in the project we have shown, we have drawn 44,000 facade tiles with a script. And if we would draw those by hand, we have calculated how much time that would take, and we are 1,114% faster than a human being without holidays and coffee breaks. So, whereas you might think that
Sorry, just to clarify that, that's basically the development time of the workflow plus the application of the
Yes.
workflow
yep,
I'm
compared.
talking about the development time of the workflow
No, no,
more
I just
than the
wanted to clarify
application.
that Sanne's calculation, because we did make that evaluation for the Valley. And so the example that Sanne just gave is the development time of the entire workflow,
yep,
the programming of the scripts and tools, and the application of those scripts compared to an estimate of what it would take a designer to draw these by hand in Revit.
So that's the power of
More than 10.
automation, but it's more than that. We automated things, but then again, we also in the end did 27 revisions. And if this was done by draftsmen, we would have to do the same process for every revision again. So developing tools has a pre-investment, so you have to invest more in the beginning, time-wise, but then you reach the tipping point in the curve, and after that, it pays itself back 10 times, and definitely more, through the not only the power of automation, but also because of automation, you have the space to design, play, and explore. So it's just a pre-investment in the beginning that pays back in quantity and also in quality of your project.
But of course, R&D. Yeah, I just wanted to add one aspect to that, which is that of course R&D always has a risk as well. So I think that's something that we learned quite well in the way that we work within MBRDV, is to distinguish between R&D that we do ourselves as an investment by MBRDV and R&D that we do as an investment by clients. And I think we take a lot less risks in ongoing projects and develop more stable solutions, like in the Valley, for instance, to precisely avoid what you're also mentioning, the possible delays because scripts are not ready or something like that. That's something that we can take bigger risks in our own innovation efforts than in projects.
Thank you. We'll go to the next question. You use software for massing, sun study, and other studies for outside the
Building, I guess.
Building. But how do you think inside the building, inside the room?
Yeah. I mean, again, I think that's, I guess at this point, maybe less through technology and more still, maybe we're still a bit more driven by manual design there. But I think that's also something that we try to address here, that the technologies we build are built within the context and the design methodology of MBRDV. And in many cases, that is one that responds to urban issues first, where the design process begins with a reaction to context, with an understanding of the role of a building in a city, and then only after that develops approaches towards the interior. But actually, the project that we have on the screen right now, or I think it's the screen is off, but the project in Paris that we showed earlier was initiated or is designed through interiors. It's just that in the tool that in the way that we look at them in the tool, these are abstracted into boxes, because for the evaluation of the algorithm and of the technology, the interiors were only relevant as windows, I guess, on daylight. And then they're already embedded in the design in the combination of the floor plans. But probably if another office would have a group like MVRDV Next, another architecture office would have a group like MVRDV Next, where the methodology starts more from the interior, I guess you would see very different tools created there. And that's also what we are really interested in this diversity of design tools and design technologies that emphasize the character of architectural offices and practices, compared to a globalization of everyone using Revit and creating the same kind of buildings.
Thank you for that. We'll go for the next question. For how long do they have to keep the analysis of the building performance once they have delivered it to the final user?
For how long? What was the question?
For how long did
I didn't get it either.
Not sure I understand the question.
Could you rephrase or help frame the question?
I'll just try to rephrase it. Maybe they're talking about how long you have to keep the data of the analysis. That's what I can interpret.
We can talk for hours about our archives. Leo specifically is quite an expert at this, but So I will pass the question.
No, I think there are two parts, like because I'm just a bit thrown off by the have to, because I guess if we talk about our own archive, it's more how long do we want to keep the data. So maybe your question is more geared towards a kind of legal requirement. In which case, I think in a project like Solarscape, there's no obligation because it's not yet part of policy. So it interprets and visualizes policy, but it's not a legal. The data that we create is not a legal document in itself. So therefore, we're not obliged to share or keep that in any form yet. I think for buildings, it's also in Europe not a requirement yet. That depends on it's done on a project by project case study who owns the buildings, the building models. That's generally, I think, a big conversation in BIM, no? Like the kind of and how far building or the building information models of a project can be used also for management and be stored later on for renovations and so on. I guess it's a case by case.
Well, yeah, it's as you say, like if you have to keep data, that sounds really boring. And actually, if you have data, it's fascinating stuff, really, data. And we've done a project which is a study into our own old data and our own archives. And we've made a complete narrative and a story and a research project about learning from our own past. And when did we generate what? And looking at that, at our own archives, is incredibly fascinating. And we see the birth of new softwares. We see when projects were finished. You can even if you look at the graphs, you can, through the email communication, amounts of mail sent and drawings made, you can predict the crisis of 2008-9. So learning from ourselves by looking at data and interpreting it and structuring it is something that's really, maybe it sounds a bit boring for you, but for us it's really exciting because if you are able to steer and utilize data in a way that gives you new insights, then you're actually you have a new tool.
Yeah. So I guess
I completely agree to that. The previous data always helps you probably reinvent something which is not done before, or continue doing something which has been fruitful in a way. So
Totally, it's about smartly utilizing what's there. This is actually what you see in all of these analyses, whether we work with the sun, which is already there, or regulations that are already there. It's all about harnessing information and being able to utilize that to make, to steer and make informed decisions. And we think that being able to steer data and structure it and harness it and understand it is a new future role and responsibility for designers.
absolutely. We all already have another question. Till now, technology has proven to be almost hazardous for our environment. With the rapid advancement and people's reliability on automated systems, we are almost losing touch with our roots and the simplicity that our ancestors used to have. How do you think technology can support practicing sustainability and fight climate change? Can they go hand in hand? I'm sorry if I've repeated any of the questions.
I think you didn't repeat any question.
Yeah, it's a very different question.
That's a good one. I mean, I would first of all, I would disagree that technology has proven to be hazardous for our environment. I mean, I think it's such a big field, right? Technology. I mean, you could also say technology allows us to communicate right now across the planet in real time, and I don't think that's hazardous for us, even though we might be producing a bit of carbon as a consequence. But I think more importantly, there's a quote that comes to my mind which goes in the direction of like it's impossible to put a genie back into the bottle. So basically, I think the scenario that you propose here of going back to our roots and build in simple ways like our ancestors is impossible. Like, it sounds good, but we cannot go back to that. I mean, the moment that the world is as connected as it is, that crisis and urgencies for housing and these kind of things exist, and the moment that we are in a situation of global capitalization, you cannot fight that to the point of just saying, okay, let's all go back and build small huts and go local. I think we are working on ways in which technology can help us to be aware, like for instance, in the case of Carbonscape, our own research project, of local sourcing of materials and be aware of the impact that things have. But yeah, now I'm repeating my answers. But I think, yeah, it's impossible to go back to something. You can only go forward. And we are living in a technologized world, and we have to build better technologies for that.
Yeah, and I think it's an extremely relevant question, and also I think the next IIDA conference, I propose that we talk about what is technology, because it's such a broad term, and sometimes we refer to technology as something that is necessary or boring or needed, but it is indeed it has many faces, like sustainability, and actually they go hand in hand, and we also need to empower and harness leverage technology to achieve our sustainability goals. We are facing the 1.5 degrees challenge and global warming, and I cannot stress this enough for everyone out there that is either an architect or a designer, that the building industry is responsible for 40% of carbon emissions, and are we feel compelled to act and behave responsible and start researching exactly that, and take our responsibility. What do those 40% of carbon emissions that come from us, from the building industry, how can we change that? How can we steer that? How can we learn to behave more responsibly, and how can we inspire others? So for anyone that has attended, please look into carbon. It's very important that we all start to change our behavior and reduce our emissions through any technology possible.
We are end of our questions and session. Thank you both. It was great having you for the session here, and it opened an altogether new perspective for all of us here. Thank you.
Thank you for invitation, attendance, and all the questions. Interesting to talk to you.
Yeah, definitely. Thank you so much. We really enjoyed it. And have a nice day. And the event.
Same to you. So now there's a break till 2:30 p.m. and post that there'll be another session immediately. Do not forget to tune in, stay safe, and please network with fellow attendees in the network lounge. Thank you.
Thank you.
Bye.
Bye.
Bye.